say we have two vectors, x and y, and let's let them be in R2 or R3. And let's let theta be the angle between these two vectors. So for example, if we have these vectors in R2, let's say this one is x and this one is y. Remember that the angle between two vectors is so there's two angles here and one here. And the angle between the two vectors is always the smallest of those. So this is going to be theta. Now we know that the dot product of x and y, we already know that this is x transpose times y, but now I'm going to give you another formula. I'm sure you've seen this formula before. This is equal to the norm of x times the norm of y times cosine of the angle between the two vectors. So let's circle this. This is an important formula. Not very good at making a circle on this little tablet. Okay, there we go. Now, another formula I want to give you involves the absolute value of this equation here. So recall that the dot product of two vectors is a real number. So since this is a real number, we can take the absolute value of it. So if we take the absolute value of the dot product, well, since the dot product is equal to this, that would mean we would take the absolute value of the right-hand side. And since these are lengths of vectors, they're already positive, so we don't have to worry about taking the absolute value of these two numbers here. And then we multiply by the absolute value of cosine of the angle between the two vectors. Now, I said that the angle between two vectors is the smaller of the two angles that you can find. So when I say that, what does that tell you about the angle? How big could the angle be? How small could it be? Well, if x and y are the same vector, then the angle between the two vectors would be 0. And if x was the negative of y, the angle would be pi. So anything bigger than pi, like if you had an angle bigger than pi, well, the other angle would be smaller than that one. So the biggest it could be is between 0 and pi. So theta is between 0 and pi. So what does that tell you about the cosine of the angle? Let's say the absolute value of cosine of the angle. Well, the absolute value is going to be between 0 and 1. So what that leads us to is that the absolute value of the dot product, or the scalar product, is going to be less than or equal to the product of the lengths of the vectors. So this is another important formula. And the reason for this is always going to be between 0 and 1, and if it's 1, then it's actually equal to it. But if it's between 0 and 1, it's going to be a little bit smaller, but it's always going to be positive. So you get this formula. Okay, great. Let's do a problem. Before we do a problem, I also want to mention that here I said these two vectors are in R2 or R3, but we could generalize this to Rn. So if we have two vectors in Rn, well, we could think of them originating at the same spot, and these two vectors form a plane. You can make a plane with these two vectors, and you could consider the angle between them. And so this formula will work for vectors in Rn, not just R2 and R3, but also in Rn. Although you can't visualize these vectors and the angle, these two formulas still hold. Okay, so let's do a problem. Let's find the angle between these two vectors. X is equal to -5, 0 transpose, so it looks like that, and y is 2, 2. So these are vectors in R2. And I also wrote here just the formula we wrote a minute ago, where the dot product is the length of x times the length of y times cosine of the angle between them. I actually want to find this angle here. So how can I find it? Well, the first thing I'm going to do is I'm going to solve for cosine of the angle. This is the scalar product of x and y over the lengths of x and y. And to find the angle, we just need to take cosine inverse. So this stuff will be easy to figure out because we just need to take the dot product of these two vectors and then find the lengths of the two vectors. We take the quotient of that and then we take cosine inverse and we'll get the angle. But this is actually something we can do without any math whatsoever because we can actually draw this. So let's see. So if I draw a plane, might take me a minute to draw this because using a tablet, okay, that doesn't look too bad. If I have a plane and I have this vector, negative 5, 0, well, what does that look like? The x value is negative 5, so it sits right here. Looks something like that. That's x. And y is the vector 2, 2. So I'll say 1, 2, 1, 2. It's right here. Say this is y. You can see there's two angles. We want the smaller angle. We want to find this angle. Now, what is the angle right here? Remember, this vector here, 2, 2, lies on the line y is equal to x. So this is a 45-degree angle. And then from the positive x-axis to the negative x-axis, that's 180 degrees. So you can tell me what this angle is. Theta is 180 minus 45, which is 135 degrees. So this problem's really nice because you don't have to do the math, but we're going to do the math just to check. Now that we have, we know what it is, let's just make sure we can figure it out with the formula. So I'm going to erase all of this. Let's leave that there. Okay. So we need to take the dot product of x and y. So what is the dot product? Remember, we multiply x1 with y1, so we get negative 5 times 2, and then x2 with y2, 0 times 2, divided by, well, what's the length of this vector? You squared this one, add them and take the square root. So that is the square root of 25 plus 0. And then we take the length of y, that is 2 squared plus 2 squared. Okay, let me erase this for now. So this is negative 10, put a line here, divided by, well, square root of 25 is 5. This is 4 plus 4, which is 8, so square root of 8. Let's simplify this. 5 goes into 10, so that's negative 2 over, and this is square root of 2, 2, 2, so this is 2 root 2. So we end up with negative 1 over root 2, which is the same thing as negative root 2 over 2. Okay. So the cosine of the angle between the two vectors is negative root 2 over 2. And now this is just something you have to remember from back in your pre-calculus days, that the angle that goes with negative root 2 over 2 is 135 degrees. So you do get, so let's write it over here. Maybe we'll put it in green. Cosine of the angle between them is negative root 2 over 2. So that tells us that this is 135 degrees. Great. Let's look at another definition. Again, this should be a definition you've seen before. So if you have a vector in Rn, you can talk about its unit vector, which is a vector in the same direction as the vector x in Rn, but has length 1. So let's say this is your vector x, then your unit vector is in the same direction. Let's call it u, but it's the vector itself divided by its length. Okay. Another definition is when two vectors are orthogonal. So if we have two vectors, x and y, and these vectors can be in Rn, what does it mean for them to be orthogonal or perpendicular? Well, that means that the dot product is 0. Remember that orthogonal is the same thing as perpendicular. So these vectors have a 90-degree angle, and cosine of 90 degrees is 0. So remember that formula, you had the length of x, length of y times cosine, it all becomes 0. This is going to be very important. We're going to use this a lot. Okay, let's look at an exercise. Suppose we have two vectors in Rn and that they are orthogonal. We want to prove the Pythagorean theorem. X plus y, the length of it squared, is equal to the length of x squared plus the length of y squared. How can we prove this? Okay, well, let's calculate the left-hand side and see if we can get it to look like the right-hand side. So I'm going to put LHS for left-hand side. We have the norm of x plus y squared. Well, what is that? Well, if we didn't have the square here, remember that this is the square root of x plus y with x plus y, right? But since I'm squaring it, I have to square this. So then this is x plus y, the inner product of these two. Okay. Sorry about that. Sometimes I have to scroll back down. Sorry. Okay. So what we were talking about, yeah, here we are. We're taking the inner product of x plus y with x plus y. So we're going to use the definition of the inner product that says we take x plus y transpose and multiply it with x plus y. Well, if we have two matrices added together and we're taking the transpose, then that's the same thing as x transpose plus y transpose times x plus y. And these are matrices, and matrices distribute. Just don't change the order that you see them. This is x transpose x plus, I'm going to take this one here and this one here, x transpose y plus y transpose x plus y transpose y. But then this is equal to xx, this is xy, this is yx, and this is yy. What is this right here? This is the square of the norm. And then remember, we said in the last video that this was symmetric. So we can say 2xy, because these are equal to each other, plus the length of y squared. And because x and y are orthogonal, that was one of our assumptions, x and y are orthogonal, that means this is equal to 0. Then this part becomes 0, and we get the Pythagorean theorem, which is this right here. Very nice. So if they're not orthogonal, it doesn't work. And that makes sense, because remember, if you have a right triangle, you can use the Pythagorean theorem, but you can't use the Pythagorean theorem if you don't have a right triangle.